Sets and their representation. Sets, objectives. Sets and their representation. Finite and infinite sets. Equal sets. Set theory is used in almost every discipline, including engineering, business, medical and related health sciences, along with the natural sciences. Set theory is more manifested in industries. For example, in manufacturing, employees set, customers set, machines set, raw materials set, consumables set, packing materials set, etc. When we use eBay or any other shopping search engines, set theory is involved. If systems like eBay stored all their items in one giant database set, then it would take a couple of seconds to get a response to our search query. What these computer systems do is split up their data into several separate sets, such as all the products for Australia, all the cars for Australia, all the Toyota cars for Australia, and so on. When we do the search query shown above, the eBay computer searches its database and finds the intersection or join of two sets. Set. A set is a collection of well-defined distinct objects, that is, the objects follow a given rule or rules. The word well-defined means that given an object and a set, we must be able to say whether that object belongs to that set or not. The objects used in the set are called elements of the set. Elements of the set must not repeat. Consider a collection of interesting books in a library. If some students are asked to prepare a list of interesting books in that library separately, you will find that the lists would be different. A book may be interesting to one but not to the other. Thus, we are not definite as to which books are there in our collection. So, the collection of interesting books in a library is not well defined. Hence, this collection is not a set. Examples. A equals to set of 1, 4, 5, 4, 8. The elements of this collection are distinguishable but not distinct. Hence, A is not a set. Let A equals to collection of all vowels in English alphabets, then A equals to A, E, I, O, U. Hence, elements of A are distinguishable as well as distinct. Then, A is a set. Some standard notation for some special sets. The set of all natural numbers is denoted by n. The set of all integers is denoted by I or z. The set of rational numbers is denoted by q. The set of all irrational numbers is denoted by q dash. The set of all real numbers is denoted by r. The set of complex numbers is denoted by c. The set of all positive real numbers is denoted by r+. 0 is not included. The set of all negative real number is denoted by r-. 0 is not included. Representation of sets. Tabular form or roster form. Set builder form or rule method. Venn diagrams. Tabular form or roster form. In this representation of a set, the elements of the set are listed separated by comma within braces. Set builder form or rule method. In this method, a set is described by a characterizing property P of X of its elements. Venn diagrams. Simple closed figures are used to represent sets. These closed figures are first used in 1880 by John Venn, an English mathematician. These figures also used by Leonhard Euler, 1707 to 1783, a Swiss mathematician. So, these figures also called Venn-Euler diagrams or simply Venn diagrams. Types of sets: empty set, null set, void set. The set of odd numbers divisible by 2. Singleton set. A set having single element is called a singleton set. It is represented by writing down the element within the braces. Example: single element set 2, single element set 0, set of non-empty sets. Finite and infinite sets. A set having finite number of elements is called a finite set. Example: set of people in a village. A set containing students of your class. A set which is not a finite set is called an infinite set. A set whose elements cannot be listed by the natural numbers 1, 2, 3 and so on, n, for any natural number n is called an infinite set. Example: the multiples of 3 are 3, 6, 9, 12 and so on. That is, A equals to set of x such that x is a multiple of 3 is an infinite set. Set of x belongs to integers such that x less than 0. Cardinal number of a finite set. The number of elements in a finite set A is called the cardinal number of set A and is denoted by n of A. Example: let A equals to set of A, B, C, D, E. Then n of A equals to 5. The cardinal number of singleton set is 1. The cardinal number of a null set is 0. The cardinal number of set phi is 1. Equivalent sets. Two finite sets A and B are said to be equivalent if they have the same cardinal number. Thus, set A and B are equivalent if and only if n of A equals to n of B. If sets A and B are equivalent, we write A equivalent to B. Equal sets. Two sets A and B are said to be equal set if A and B have same cardinal number and they have the same elements. If set A and B are equal, we can write A equals to B. Summary.